Today we're going to look at absolute value functions and their graphs, and we're going to identify some of the characteristics of their graphs. You can graph these by hand, or you can use your graphing calculator. The vertex does come from these two numbers, just like it did when we were graphing parabolas. The inside number is your h, and you will need to change the sign of the h. The outside number is your k, and it will remain the same. So my vertex is at +6, +3. To find a y-intercept, we're going to put a 0 in for the x. When you do that, you are going to have to solve your equation. If I have 0 minus 6 inside the absolute value, that gives me -6. And when I take the absolute value of -6, I get +6. When I add it to 3, I get 9. To graph this, I have a point at 6, 3, and I know I have a point at 0, 9. I'm going to go ahead and draw my lines. And now I have an idea of what my graph looks like. I can identify the x-intercepts at this point. We only have an x-intercept if it crosses the x-axis, and this one does not. Max or min. The vertex is the lowest point on this graph, so it is a minimum. And remember, when we talk about max and min, we're only referring to the y values. So the lowest y value of this graph is 3. Domain. Domain tells me how far to the left and how far to the right my graph goes. This graph goes infinitely left and infinitely right. So my domain is -infinity to +infinity. Range. Range tells me the lowest y value to the highest y value. The lowest y value that this graph goes to is 3. And remember to use brackets because it does stop there. The highest y value is +infinity. Increasing versus decreasing. Remember, just like with a parabola, the axis of symmetry divides the graph into two parts. And that's where we're going to see that change from increasing and decreasing. Remember to start on the left and work your way to the right. So this side of the graph is decreasing. It would be decreasing between -infinity and +6. This side is increasing between 6 and +infinity. Make sure that you write your answers on the correct line. So increasing occurs between 6 and infinity, and decreasing from -infinity to 6. End behavior. As x approaches -infinity, we're talking about the left side of the graph. Where is the graph headed? It's headed to +infinity. As x approaches +infinity, the graph is also headed to +infinity. Transformations. What has this graph done to move from its origin, its original parent function, to where it is now? If you pay attention to your vertex, you'll know your movement. Starting at the origin, I had to go 6 right and 3 up. 6 units right, 3 units up. Since there isn't an A term, there was no vertical compression or vertical stretch. And since it's positive, we did not reflect over the x-axis. All right, in number 2, we're going to use a graphing calculator just so you can see how we can identify things in the graphing calculator using our table of values. To enter our equation into the graphing calculator, make sure you go to your y equals and clear out any previous equations that were in your calculator. If a negative comes at the front of your equation, use the negative button at the bottom of your calculator. To enter a fraction, you can choose alpha y equals, enter, and then you can put in your fraction, 1/3. To enter your absolute values, go to Math, go to the second column, and choose option 1. We're going to put x minus 3 inside, and we'll put the positive 2 on the outside. Now remember, if you don't have your table of values showing, you'll go to Mode, and you'll go down to Graph Table and select this option. To use your table, you're going to do Second, Graph. And in this case, I know that the vertex is around 3, so I'm going to move down so that I can see where my vertex is. Again, I could look at the table and look for the pattern, and that would help me also. So my vertex is at 3, 2. I'll write that down in just a second. But as far as x-intercepts and y-intercepts, I also want to show you how to find those on the table. Remember that a y-intercept occurs when x is equal to 0. So you can find when x is 0, and I know that y is 1. I could also use the cursor to see that it is indeed sitting on the y-axis at that point. To find my x-intercepts, I want to look for when y equals 0. I'm going to continue moving up the table. You can see the first x-intercept is at -3, 0. If I want to find the other x-intercept, I'll go down the table, and I can see that it is at 9, 0. So let's go ahead and fill in this information. My vertex is at +3, +2. My y-intercept is at 0, 1. I have two x-intercepts at -3, 0, and 9, 0. I'll go ahead and sketch this graph on my provided graph. So 3, 2, it's right here. Y-intercept at 0, 1. X-intercepts at -3, 0, and 9, 0. All right, so now that we have our graph on there, does it have a maximum or a minimum? The vertex is the highest point on this graph, so it is a maximum, and the y of the vertex is 2. Domain, this graph also goes infinitely left and infinitely right, so my domain is -infinity to +infinity. Also, I do want you to realize this just represents all real numbers, and another way you could write that is an R with a double line. The range, what is the lowest y value this graph goes to, and what's the highest? The lowest is -infinity, the highest y value is 2, and that side gets a bracket. Increasing versus decreasing. This graph is increasing on the left side, between -infinity and 3. And then it's decreasing on the right-hand side between 3 and +infinity. End behavior. As x approaches -infinity, on the left side of this graph, it is headed to -infinity. The right side is also headed to -infinity. As far as transformations, the vertex tells me that I am going right 3 units and up 2 units. This does have an A term, and the A term is negative. The negative tells me that I reflect over the x-axis. The A term is a fraction. If my A term is a fraction, then I have vertical compression.